Hello everyone, we are back with a new episode of APIM Hotrod, and today we are here with Dina. Hi Dina, how are you?
Hi Massimo, hi Stefan, I'm good. And you?
Hey, Dina. Yeah, Massimo, today what will be the topic?
Uh, Today
Uh,
I would like to start with a question that I heard a lot in these days, or a topic that it's really a trend topic. So because of the all of this geopolitics situation, right? I heard a lot talking about confidential computing and also a lot about sovereignty. But sometimes there is a confusion between these topics. What is one? What is the other? Is the same things? Are different things? So it would be nice to start, and maybe Dina, you can throw some lights about those two things. Are the same things? Is one things or two different things?
Yeah, thanks for the question. That's a great question, Massimo. So basically, there are indeed overlapping of those two domains. So confidential computing is been there for a while, so it's not new. So it's the concept is about that you have a more costly but also more secure hardware in a sense that the data is encrypted on all layers, not just in the move and in transit, but also in use. So that basically means the memory part is also very protected. But if I look at sovereignty, indeed, I've seen a lot of people discussing and what is actually, you can interpret sovereignty from the regulatory perspective. For example, as you mentioned, that current geopolitical tensions make companies think more about like who can actually see my data. And on the US companies, so our cloud providers, top cloud providers, Amazon, Microsoft, Google, they're all US based. So what actually happens if US government requests the keys, and how realistic it is so to like have your data leaked from that sense. So that's basically where the sovereignty emerged in Europe. There are some legal framework that are being published recently. So in October last year, the European Commission released the first version of sovereign framework, which basically has different criteria from, let's say, independency on the, let's say, hardware level, software control, the resiliency. And so there are 8 different categories that will be used to assess the overall score, how sovereign you are. And that's something that is now actively spoken about.
And data, Dina, is actually only one of the pillars, right, of of sovereignty, because it's also the dependency, the ability to, let's say, a cloud provider could like stop your service, right? So even though you would not access your data, still it could have some influence on making the service still available or not. But okay, in Europe today, I mean, if you stick to cloud providers somehow, accept the data sovereignty aspects, it's harder to go beyond, right? Or do you have a
so basically you have like, indeed, so when you store the data with the cloud provider, you trust the cloud provider, right? So you have the concept of encryption at rest. It's clear. Then you have encryption in transit when the data travels. But then actually what happens, because you cannot compute the data when it is encrypted, right? At a certain point of time, you need to use the keys, whether it is platform or customer managed, to decrypt the data. And there is a short period of time when that plain text is stored in memory. So if we get all discussions about trust from purely, let's say, hardware technical, so it is possible for a hypervisor or for CPU to get the view on this. And that's what's where the whole discussion about customer managed keys emerging, but it's more than that. So it's about the whole process of where confidential compute comes in the picture, remote attestation, and the encryption keys.
Yeah, maybe it's indeed, because indeed might not be clear for everyone, but it's indeed worth to mention that when we bring our own key, we actually don't bring our data encryption key. We bring the key encryption key. right? And so meaning at some point, indeed, this key needs to be unwrapped to really have the data encryption key, which could be indeed visible by, or let's say in the memory of computers. And so that's where encryption-in-use can help, like really hiding all these keys as well.
And even on top of that, so there are some interesting discoveries that I heard last week from the leads of Intel, that even those confidential compute, they are constantly improving, because there was some series of sophisticated attacks that were the physical attacks that were targeting that memory, let's say, of the hardware block, to flip the bits and to fool that confidential, let's say, supercomputer. So basically now there are a lot of improvements being made, so which makes it still quite a costly solution. However, the involvement of all these big companies does show that it is a direction that will be maybe coming a next new industry standard, like encryption was some time ago.
Yeah, I remember, for example, that a couple of years ago, Microsoft also, when they were talking about confidential computing and Azure, one of the statement was, in 5 years, 10 years, whatever it will be, everything will be confidential, right? So it will happen one day or the other that this technology will be made sure, it will be not costly as today, and then it will be like sort of a commodity, right?
Yeah, I think that there are also a lot of, indeed, that's a good point, because we are moving also in the era of AI to do we need like hardware power, and it's somehow contradictory with let's say European sustainability green regulations, because that's where like it can be challenging to, let's say, scale and at the same time to respect all the requirements. So it is challenging, but there are a lot of things happening over there.
And
go ahead. Actually, to link with AI, I kind of remember that the initial use case of confidential compute was actually for AI. Because basically, you know that when you train models, the more data you have, the better trained they are typically, and the most performant. But of course, the more data from different customers you have as well, you see. And so the encryption-in-use was also a way to isolate customer data, or at least make sure that it could not be seen in clear in the memory. I think that was one of the triggers even of confidential compute, if I remember well, but it's a long time ago. I have not studied that today. But I think that was one of the use cases. But no, okay, it has like expanded to beyond this. But then Dina, okay, because in Azure today, okay, you can have confidential VMs, you can have confidential nodes in AKS. But still, it's not, as Massimo said, okay, 5 years ago, Microsoft said it would be everywhere, but today it's still not what I see on the field. So what is your impression? Do you see that also being adopted more and more by your own customers? Is it still a challenge? What do you see?
I think if you purely look from the technology perspective, no doubt there is a lot of interesting possibilities. But as we discussed just before that, it all drills down to the availability of hardware, cost, and basically the valid business justification. For example, recently I would not name a customer, but we did have a government entity from the Europe that came with a problem statement that the healthcare fraud analysis is very difficult to do without certain data and AI features. Yet they need to respect the European AI Act, and they still need to have like human intervention, but they really need something like confidential compute. So we sit together and we build a design that is using confidential nodes, Databricks and data processing service on Azure, and that was passing the assessment against the all AI Act and confidentiality, and that is now being rolled to production. But as we discussed, it is very costly, so there should be. Here there was a really good use case because there was a very big part of budget going on those healthcare benefits without any possibility to detect fraud. And now that type of confidential use case is really solving the business problem. That's one of the cases that I was working on. But I think next in line, it could be very interesting also for the financial services, although the value there is at the moment, from my perspective, slightly less than for the healthcare, where the insurance cost is really making
a difference. Because my experience in financial sector is that indeed, typically pure financial data itself is actually not considered top secret data. It's often considered like secret data, but not top secret data. So then indeed it might sound overkill, let's say, to use consider compute for these type of data. But
although I seen a update recently, there was the company in Leuven that co-developed together with Swift the mechanism of the accelerator. So that, as I mentioned earlier, the IS encryption is not computable, right? You always need decrypted, and that's where the issue arises. But they build the accelerator service that transforms that uncomputable encryption to there is a very fancy word, homomorphic encryption, but basically it gives a possibility to work with unencrypted data. And it used to be really slow, but one of that announcement recently, I was very excited, and I would definitely follow up on it, that Swift co-developed it with a company named Belfort. And they are actively investing in it because that opens up a lot of possibilities for financial cases without decrypting the data.
Yeah, like when I know that you, Dina, you work closely with a regulated industry and also public sector, right? So, and when I think about public sector, and if I just put a regulation plus confidential computing, the first thing that I think is an explosion of cost, especially when regulation is extreme, because extreme regulation tends to bring things on premises. And then you have not only the complexity and the cost of the hardware, but also the limitation of the software that you might use, right? Because I think like, for example, all of these beautiful data bricks or things, then when it goes on premises, then you have to, those products are mainly cloud, and then you have to just go with your building up again completely your clusters and your solutions on premises, just like I'm just exploding. I see costs everywhere. So how do you see going in the public sector?
Well, I think there always should be as I said, the use case. So for that project of ours, there was a big problem that a lot of, let's say, governmental money went on this in that area, and it needs to be solved. And there, the business case was actually in favor of going for use confidential. I also think now there are a lot of effort to, let's say, bring down the cost to build some sort of mechanism of co-location. Intel and NVIDIA leads were discussing it last Friday. So they recognize the cost is a blocker. The cost should be resolved. But I think if we look even on Asia, if we look on the different generations of compute, every later generation, the performance was going up and the price was going down. So that's easy.
I think one of the challenges today, Massimo, is okay, cost is one thing, but indeed, if you have the business case, then it's fine. But it's also just the possibility. If you just stick to Azure or cloud in general, look at all SaaS services. Are they using confidential compute behind the scenes? Most of them not, right? So meaning that if you use a SaaS service somehow, then you accept the fact that it's not backed up by a confidential compute node. And then even PaaS services in Azure, you have little exceptions like Azure SQL with always on, always encrypted, secure enclave, and so on. But most of them are also not, using confidential nodes. Yeah, so that's, let's say, one of the limitations today. So for me, if the offer expands more to IaaS and let's say containers, and that you can really have this for all service stack, then at least you could have the possibility to go there. But in some cases, it's just not possible because it's not offered even as a service.
Yeah, that's a good point, Stefan, because those multi-tenant services, they are hosted, so they are not isolated or dedicated. So that's already known, accepted by the customers. In this case, I think the confidential starts with those like sensitive workloads, the one that, especially with GDPR. So you have those terms that can link or linkable to the person, which even sometimes IP address or smart meter number can be interpreted as a sensitive data. We had the cases, let's say, when the automotive customer had to encrypt, anonymize the data that was coming from vehicles before doing anything with it. We also had their smart meter numbers, like EN numbers. In Belgium, for example, they are identifying some household, which is falling under European, let's say, GDPR principles. So that's where, let's say, additional complexity is introduced by regulation. So I think regulation would be one of the drivers of this. But it is likely at a certain point of time with the AI evolution and the hacking activities that we may have a certain standard that would be, let's say, recommended or preferable to be in place for some companies in Europe, at least.
But like one of the things that I was so when I saw let's say confidential for the first time some years ago, and I was very confused, to be honest. It's not my strong expertise here. One of the things I was wondering is like, I mean, I understand the machine, but then that machine, he has to run everything in that box to be confidential. What is the definition of a confidential when it's a matter of an application? Because an application has a lot of dependencies, or it might be dependencies. So if the dependency goes out of the boundaries of my machine, am I losing the confidentiality stamp? Yes or no? So I know it's a weird question, but like I was always confused about like where it begins, where it ends.
I'll let Dina answer, but I have the answer, Massimo. But Dina,
go ahead.
I think Stefan earlier mentioned that like the process of encryption, it like consists of, it's called envelope encryption. So it consists of the two keys. Like there is like a master key, and that's where like you may have seen also sovereign confidential discussion comes together with CMK, customer managed key. So basically that's a key that's in combination of those two keys you use to decrypt your data. So think about I don't know, you have the database with sensitive data that you encrypted, and then but you want to process it. Let's say I want to analyze something like for the fraud, or if I should give the mortgage, or if the behavior of certain individual of his history is good enough. But I cannot do anything with encrypted data unless you use that homomorphic encryption. So you need first to use that key to decrypt the data. And that's where the confidential comes into play. So at short point of time, your CPU, so your machine, let's say you have root access, right? At short point of time, you have that plain text decrypted value in memory. So if you don't trust, if you have zero trust whatsoever, but you have root access as admin, you can technically get that plain text and then get yourself that decrypted data, which would be the breach of the confidentiality, of course. That's why that confidential name emerged, that you basically encrypt on 3 levels, not only rest transit, but in use.
Yeah, you see, Massimo, that's the thing. So when you leave the boundaries of the machine, then it's going to be an encryption in transit. Then it's another type of encryption that covers you, right? So if you reach out, let's say, to an API that's like a third-party API, so as long as you make sure that this communication is encrypted using the not encryption in use, but encryption in transit, then it should be okay, right? So it's really, the encryption in use is really to actually protect the memory. So make sure that anyone that can access this memory is only authorized to do so through the, I forgot the name, but anyway, there is an authorization service that gives you access to these secure enclaves.
That's
right?
Stefan, you're referring to attestation. So basically when the SVM boots, you need to actually prove that you are to be trusted, right? So, and that's where like that goes together with that remote attestation mechanism. Different vendors, Intel has it, Microsoft has it. So it actually says like, hey, I am the VM. Like, am I reliable? There are different, like with Intel, with the latest processors, they do like health checks, they do scrubbing to see, okay, did someone interfered and like inserted some interposer in my, let's say, motherboard to flip the bits. And only then you can actually grab the key. So if it would be managed key vault or any, let's say, external, bring your own key, only if you trust it. So that's, and sorry, I interrupted you, Stefan. Please go ahead.
No, but that's indeed correct. And then I would say maybe last topic that we could slightly tackle, you also already mentioned key vault. So, okay, say that even for encryption at rest, right, you bring your own encryption for key encryption key. But so, okay, today, what would you recommend between Key Vault Standard, Key Vault Premium, Managed HSM, Cloud HSM, and okay, now that we know that dedicated HSM is like deprecated, I mean, what do you see? What's the trend you see with your customers?
So I would say, let's say, unless you are really required by regulation or whatever experience, be simple, because you don't want probably to have extra costs, and there are the key vault by itself as it used to be, let's say not a premium, is already the cloud service. If you work with a PaaS, multi-tenant services, it can't be really different from you for not accepting key vault, because not only you have a cost when you go with the highest level, but you also have a performance impact on this. So, and it can grow exponentially. So what I typically recommend to my customers, unless you're regulated, just go with the standard offerings. Of course, follow all the best practices of like zero trust if needed, but offerings like latest, as you mentioned, dedicated, or now it's called integrated, because Microsoft is planning to actually have that custom chip of the FIPS level 3 in every server, which already means that you can use cloud managed HSMs. But yeah, I would say like be simple unless you need to be complex.
No, okay, but that's a good advice. That's basically also what I advise typically. So,
Stefan and Dina, we are almost at the end of our call, but if I can have one last question.
Yes, go ahead.
So you mentioned that you just last week or so you've been to a conference about confidential computing with some major players. You mentioned NVIDIA, Intel. I suppose there are a bunch of, I mean, way more. And my question is just, what is your opinion whether those big players are going towards some sort of standardization? Standardization, I don't know, in the attestation or whatever. So how do you feel are really playing towards the standardization? And so how do you see it from your side?
What are the key takeaways, basically, right?
Yeah. So there is indeed the tendency of going towards something like, as I said, maybe we are becoming new, let's say, encryption standard, because there is like a triangle of so those vendors, then you have standards and you have regulation. Regulation cannot enforce something unless you have standards. And then like vendors and cloud platforms, they also reflect basically the needs of the market. So what I've seen, there was a lot of focus on the, let's say, confidential evolution, also based on the, let's say, the possible vulnerabilities. There were a lot of trends on improving the compute power to do like sharing. So you can see that there is a growing demand. Otherwise, those companies would not be there investing in those services. And if you want to purchase stocks, then maybe those are the good ones.
Good tip.
But, yeah.
All right. So everybody is fighting on the hardware, let's say, and maybe standardizing a little bit on all the mechanics around it.
Yes, it makes it difficult in Europe that there are so many different countries that actually, yes, you have European regulations, but you have also national bodies that can, like in Germany, they already started interpret it in their own way. So that can be a bit of a blocker, but I do expect that that conference was a confidential computing consortium. So those type of organization that has those key players in it would probably be driving, if not the standards, but let's say recommended architectural patterns that could be, let's say, implemented by each country, because in Europe, every nation can interpret it in their own way.
Indeed, that's.
Okay, wonderful. So it was a great discussion. So now if I have any question about confidential computing and regulation, I know who to call, who to just drop a message. So that's, great. It was a great chat, Dina, Stefan.
Yeah, thank you, Dina. Thanks a lot for having joined us today. Very interesting discussion indeed.
Thanks, Massimo. Thanks, Stefan.
Thanks. See you.
Bye.
See you. Bye, everyone.
Bye.